Good day, Computer Science 2A. In this tutorial, we're going to talk about game development. And in order for this to work, we're going to be talking about the principles of game design. So let's see what we're going to do today. We're going to talk a little bit about what game logic is, what a gameplay loop is, how to interact with players, and what exactly the game mechanics are and how to then use them. So what is game logic? And then how do we design a game to implement it? So first and foremost, a game is a form of software that is used for entertainment. Alternatively, games are used as a form of competitive sport, but ultimately what we're aiming for here is that a game must be fun in some way to warrant it being played. So if a game is not fun, people are not going to want to play the game. And who are these people? Well, normally when we refer to software, we refer to the users of the system as the people who are going to be interacting with the software. When it comes to game development, we're commonly going to refer to these much cooler people as the players of the game. Usually, player one if there is a multiple players. For those of you who have played games on old consoles who have multiple player inputs, they usually have your player one, your player two, and so forth. So how does this all work? Well, when someone plays a game, it means they interact with the software through controls. And the way that they interact with the software is going to be through button presses and mouse clicks or controller button inputs or something like that, like a joystick or some other kind of controller. But the way that they interact is that they utilize these inputs to then interact with what are called game mechanics. They're the things that you do when you press the buttons to then achieve some kind of a goal. So what we have here is that software in the form of video games can be generalized into three very broad states. We have the start of the software where the player presses start and everything is then prepared. And then once the player is done, they will have entered into what is called the end state or the goal. This means you've won the game or you have lost the game. But in order to get from the start state to the end goal or the end state, you have to go through what is called the gameplay loop. Now, the gameplay loop is where the software takes input from the user and then processes it in the form of game mechanics, displays results to the user, and this process is then repeated while checking the state of whatever your game mechanics are to see if you've reached the end state. So the end state is going to be different from one game to the next. Let's look at an example. So here's the game of chess. The chess is a physical board game that also has software that you can play if you want to play chess against a computer. Now, the start state for chess would require that you have a board that is set up with all the pieces in place. It has it that the players are ready to start playing if it is a two-player game. Alternatively, the player must be ready and the computer will automatically be ready. Then the assignment of colors takes place. Either they take the pawns on the black side or on the white side. And then the game will have to have some kind of a timer that will start at 0 to then test to see how long each player plays for. Okay, so once all of this is set up, the timer is set to 0, all the pieces are set up, the people are sitting on the right side of the board that they're assigned to, the board is completely set up, the game can actually now begin. Now what will happen then is the players will begin playing the game. This is where we actually get to see the main gameplay loop of how chess works. So this will start by having the first player make their move. So that player will need to make a decision in their mind about what piece they're going to move. Now, there are different gameplay mechanics that are going to now take place, or rather be interactable with, to enable the user to make their moves. So certain pieces can only move in certain ways, like a king can only move one space at a time, a pawn can move in a straight line, and if you've got something like a knight, they have to move in like an L shape. So these are different game mechanics which require that you move the pieces differently, which means the player playing the game needs to have some kind of knowledge of what these game mechanics are in order to move their pieces effectively. So let's say the player wants to move their pawn. He will then initiate the command to move the pawn from a particular place to another place. What will happen then is the player has made their move. It is now no longer their turn. The timer for that player will stop, and then we'll switch to the other player. And now we can see why it becomes a loop, because the next player will then do the exact same set of steps. They will make their decision to make a particular move. They will then, once they've made their move, stop the timer and then change player and repeat this process. Now, this process, known as the gameplay loop, is going to continue until one of the end states or goals of the software has been achieved. So in this case, the goal of chess is to checkmate your opponent, which means that the king of the opponent cannot move anywhere without being checked by a piece that belongs to the other player. Now, there is another way that the game can end where the player decides, well, I can't physically win, and concedes the game. So let's say the player concedes, the game will end, and then you can start the next game. But now, every time a player makes a move, we will need to check to see if the opponent has had their piece checkmated. If it is checkmated, then the player who has done the checkmating has won the game. So at all times, the gameplay loop must be aware of what end state or goal it is checking for to determine whether or not there is victory or loss. So the player that does the checkmating will then be the victor, whereas the player who does have their piece checkmated will then be the loser. And then once the end state has been reached, it can all be started over in a new game. So let's look at a more modern example of a video game. So let's look at a game like Fortnite. Fortnite is a giant, ultimate, very popular battle royale game, and Fortnite has the same process, although it'll have different things taking place at each one of these states. So at the start of a Fortnite game, you're going to click join game and you'll be loaded onto the bus, and then you get told you can then deploy and you jump out the bus and go down to the island. So that'll be the start point of your Fortnite gameplay experience. Now, once you've landed on the island, you then begin the gameplay loop. But then what is the goal of Fortnite? The goal of Fortnite is that you are the last person standing. That is when you win. If you are the last of the 100 people who entered the game, you are then the victor. Alternatively, your game ends if you are defeated by another player. Okay? So at all times, we need to get from the start where we jump out the bus to the end state where you are either the victor or you are defeated, thus concluding the game. Now, this is done in multiple different ways. So the gameplay loop of Fortnite is usually you go around either killing opponents or looting boxes to get equipment. You then use that equipment to eliminate other players, and you can utilize the things you have looted to build stuff that will hopefully enable you to do the process better. This then becomes your primary gameplay loop. You loot something, you eliminate opponent, you loot them, you eliminate the next opponent, you do some building, and so forth. Thus, a loop is formed while you go through the game, hopefully eliminating enough people that you are then the last person standing. So this would be a very rough outline of the gameplay loop of the Fortnite game. But now let's talk a little bit more about how the interactions with players will take place, because the way in which things take place within a game of chess and in a game like Fortnite are very different because of the way that we interact with the player. So we have something that might be familiar to you from Computer Science 1A, which is player-driven interaction, where the computer program is going to wait for the player to input something. So remember back to your games from Computer Science 1A, where in order to progress the game would ask you what move would you like to make. You then input the move like up, down, left, or right, which would then move the player in the game world, and then move on to step 2, which would then compute the game logic, which would then determine what exactly would happen. Would you collide into something? Would you pick up the thing that you needed as your objective? And then finally, you would display the resultant game state. So nothing would happen until the user inputs their selection of command that they want to perform. So this is ultimately driven by the player, hence called player-driven interaction. So the game logic doesn't do anything until the player presses the button and presses enter, or they press the key on their controller, or whatever the input is that the game is waiting for. Then and only then will the game logic be computed and display the resultant state. So as you can see, the latter two stages of game logic and displaying the game state are all dependent on waiting for the player to input their data. Whereas let's have a look at a game like Fortnite. Fortnite, if you were to land on the island and not touch your controller at all, the game would still continue playing. You as the player have just elected not to put any inputs into the system, which means your character will not move about in the world. They will not execute the main gameplay loop for what your character is doing, but the server running the game is still going to facilitate all the other players doing their gameplay loops, which means someone can come along and see you just standing there not inputting any controls, and then shoot you, and then your gameplay loop will end because you have reached an end state even though you have not put in any data. Another good example of this is the game of Tetris, which is widely available and wildly popular. So I suggest you have a look at a game as simple as Tetris, because Tetris is built upon a principle called continuous interaction, wherein no matter what the player does, the game is going to continue. You are given a set of polygons that are made up of little blocks of varying shapes. Some of them are straight lines, some of them are shaped like T's, some of them are shaped like L's, and they all fall from the sky. And you need to then rotate them and slot them in to complete a full row. Once you've completed a full row, it will then remove the row and make it so that your tower of Tetris blocks doesn't build up to the top. Because once a block reaches all the way to the top, you lose the game. Okay, so we'll talk a little bit more about that later when we talk about some game mechanics, but you'll note that in either of these examples, whether it be Fortnite or Tetris, the player's input is entirely optional because the game logic is going to continue running. In Tetris, the blocks are going to continue falling from the sky. If the user then inputs some controls, then that will affect the way that the game logic works, and thus the state is displayed. So if the user were to get up and walk away from their keyboard, the game is going to continue running and the state is going to continue being displayed on the screen. So it's in the player's best interests, obviously, to put in inputs to win the game, but even if they don't put in inputs, they'll eventually reach the fail state, or the end of game that they lose. Okay, so that's how the two different forms of interaction basically work. At this point, you'll be more familiar with player-driven interaction because that's how your games to date have been built. Whereas today, we're going to discuss more this continuous interaction, and I'll give a tutorial on how to implement this in JavaFX to have some more dynamic and continuous running games. But let's talk about game mechanics, because the primary gameplay loop is ultimately made up of gameplay mechanics that the user, in this case the player, will need to interact with. So what are game mechanics? Game mechanics are programmed constructs that are used as part of the gameplay loop. More specifically, they are used to enable the player to achieve the end state or goal. So a game mechanic will therefore vary depending on the type of game being developed. For example, in chess, you need to have the ability to move individual pieces. You'll move a knight, you'll move a rook, you'll move a pawn in different ways. You need to have the gameplay coded in such a way that all of these operations are doable. You also need to have the ability to time each player so that the player doesn't spend an eternity figuring out what their move is going to be. You also need to have the ability to swap between players so that the other player can then do their moves. You also need the ability to check the game state against the end goal of the program, which is to check for the checkmate that we're looking for to determine who the winner is going to be. So these mechanics are determined by what the goal of the game is going to be. Likewise, if you look at Fortnite, you need to have the ability to choose who your player is so you can log in and then board the bus. You also need to have the ability to loot items so that you can then enable that gameplay loop that you can then use the weapons to assign damage to a player. Therefore, there needs to be the ability that once someone gets shot with a weapon or hit with a weapon, that they can take damage. And if their health reaches 0, they should therefore lose the game. So that then will have a set of mechanics that are built specifically to address the end state of the game. So there are other things like being able to build, being able to break things, and so forth, all being part of the mechanics. This is a very, very tiny subset of the mechanics required for a massive game like Fortnite to actually work. There will need to be things like game timers, timing all the players, and maps that can update showing where you and your friends are, and lots of other things. So even though these two games have followed the same process, they have a start point, an end point, and a gameplay loop, the actual mechanics are going to determine how the one game is implemented differently to the other. So I have some homework for you guys to do, and that's to go and find 1 or 2 games on the eShop that you, or ones that you like playing. They should be free, preferably, and your homework is to go and play the game, not excessively, but just enough to get a good feel of what the game's about. And then what I want you to do is I want you to identify what the goal of the game is. Is it to survive for the longest period of time? Is it to figure out what the mystery is in the game? Is it to just get to the next level? Is it to get a high score? That will be the goal of the game. And it's usually illustrated very well so that the player knows what to do. The next thing you need to do is figure out what the gameplay loop is that goes along with that game, and then try and figure out what the mechanics are that you are interacting with to then achieve the goal. Okay, computer science, thank you for this.